L'Hopital's rule, introduction and solution to basic problems. Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. Today we are going to learn a very interesting and extremely useful concept in engineering mathematics, that is the L'Hopital's rule. This topic is favorite in VTU exams, and trust me, it's one of the easiest and scoring topics, and you will surely expect a 6 to 7 marks questions from this in your VTU exams. So what is this L'Hopital's rule? See, L'Hopital's rule is used when solving limits and we end up with an indeterminate form like 0 by 0 or infinity by infinity. So let us understand how to apply it. And as you all know, I am undergoing cancer treatment. So as long as I can, I want to continue teaching and sharing my knowledge with students like you. So if you are new to this channel, then please like the videos, share these videos with your friends and classmates as much as possible, and please don't forget to subscribe. Although the L'Hopital's rule looks easy, it's nothing about differentiating the numerator upon denominator, but still many of the students make mistakes here while applying it and they end up losing marks. So I am going to explain you in a very easy and understandable way so that you can easily remember it and get the correct answer without losing any marks. Okay. So now the first condition for L'Hopital's rule is the question should be fraction. Okay, I am going from the basics here now. The question needs to be what? Fraction, the first condition. So right here, the question needs to be a fraction. So what is the fraction? Fraction means numerator by denominator. It is nr by dr. The next step is, for the question given, we assign k. So assign k. The next step, when you assign k, then you get k is equal to, say the question is limit as f tending to a function of f of x upon g of x. See the question here, f of x function of x whole divided by g of x, and limit is x tending to a is a fraction, and we assign the value equal to k first to solve. After assigning k, apply the limits, and after you apply the limits, so right here, after applying the limits, we get, so what's the limit here? S test a. After you apply, what a limit is given after applying the limit, if we get what? 0 by 0 or infinity by infinity only. Be careful here, because when you get something by indeterminate form, you jump up to apply the L'Hopital's rule. It's not like that. Many people fail here. Remember, the compulsory condition is 0 by 0, only 0 by 0 or infinity by infinity only. Then only you can apply the L'Hopital's rule, otherwise you cannot. It's not merely about simply differentiating the numerator or denominator. This is condition. The condition is what? You should get 0 by 0 or infinity to infinity, then only you can apply L'Hopital's rules. Then the L'Hopital rule says, if you are getting the limit as 0 by 0 or infinity by infinity, then by L'Hopital's rule, what L'Hopital's rule says? It says k is equal to limit as x tends to a f dash of x upon g dash of x. That means you are differentiating here, differentiate numerator and denominator separately. You need to differentiate the numerator and denominator separately here. Again apply the limit, again apply limit, and after applying the limit again, if you are getting, if we get again 0 by 0 or infinity by infinity, then we need to again reapply the L'Hopital's rule. So again by L'Hopital's rule, k is equal to limit as x tend to a f double dash x upon g double dash x. Again differentiate numerator upon again differentiate denominator separately. Now you need to keep on applying this. Keep applying L'Hopital rule. That is again if you apply limit, say if you get 0 by 0 infinity by infinity, again apply. So you will keep on applying it until k is equal to 0 or a finite number or a finite value. This is the L'Hopital rule. That's all. I hope understood this. So what to say is not merely about differentiating the numerator upon denominator. Question should be fraction. Assign k first. Very important. Assign k. After assigning k, you need to check the limit. The limit should be compulsory 0 by 0 or infinity by infinity only. Then only we apply L'Hopital's rule. Here, what does L'Hopital rule says? Differentiate numerator upon differentiate denominator separately. What? Separately. Then again if you apply the limit, again we get 0 by 0 infinity by infinity, again apply, again check the limit, again apply, keep on doing this till the answer is 0 or a finite value. This is how the L'Hopital rules work. Please understand this. Have a basics right, you will be able to solve any problem without ease and get the full marks. There is one more concept here now. Now, when the question is of the form, when the question is of form, say powers, okay, like of the form f of x whole raised to g of x, like function of f of x whole raised to function of what, g of x. If the question is like this, then what to do? In this case, first what always have to do, first assign k. So k is equal to say limit as x tends to a function of f of x whole raised to g of x. And here the form will be like, the indeterminate form will be like 1 raised to infinity, 0 to 0, infinity raised to infinity, and so on, like this. Okay. Then if like this, after applying the limit we get forms like this, then what to do? Very simple here, apply log on both sides, on both sides. So simple thing, if we want to, log is a powerful tool which brings something from top to bottom. So something is for raised to is there, if you want to bring it down, we always apply log. Okay, so apply log on both sides. That means we have log of k is equal to limit as x tending to a log f of x whole raised to the function g of x. Now, as you know the principles of logarithm, what's it? It's log of a raised to k is equal to k log a. What is that? Log a raised to k is equal to k log a. That means this will become now log k will be now limit as x tends to a g of x. So this will come down into log of f of x. This is what you get. Then for this you have to what again? If it is a fraction then okay, otherwise make it a fraction by the basis what you know. Then what will you do here? Is the fraction okay or make it a fraction? Then what? Simply apply L'Hopital's what? Rules. What does it say? If again after fraction if the answer is getting 0 by 0 or infinity by infinity, then differentiate the numerator and differentiate denominator separately till you get a finite value. So here keep on applying the L'Hopital's rule till you get log k is equal to say L. Okay, L is a finite value. Therefore, that implies if log k is equal to L, then what is k is equal to? E raised to L. That's it. This is how it is done. to understand L'Hopital's rule perfectly, we start solving with some basic simple questions here. So, the first question is evaluate limit as x tends to 0, x e raised to x minus log 1 plus x in the numerator whole divided by x square in the denominator. So, first what to do? This is a fraction, done. So, we can easily apply the L'Hopital's rule. Next condition is what? Assign k is equal to what? First assign k is equal to, so we have k is equal to limit as, go step by step, x e raised to x minus log of 1 plus x whole divided by x square. Go step by steps. Solving mathematics problems is a discipline. Maintain it, please. So, after doing it, what is the next step? First fraction, assign k. The next step is apply the limits here. So, what is the limit? 0. When you apply 0 into e raised to 0 minus log 1 plus 0 log 1 upon 0 square. So, this will be now how much? Tell me. 0 to 0, 0 only, log 1 is 0, always log 1 is 0 upon 0. So, we get 0 by 0. So, once we are getting 0 by 0 or infinity by infinity, we can happily apply the L'Hopital's rule. And what does the L'Hopital's rule says? K is equal to limit as x tends to 0, differentiate the numerator upon differentiate the denominator separately, keep in mind. So, FC here product rules or quotient rules we used, and here x e raised to x is product rule. I am telling once again the product rule. The product rule says that differentiation of first into second function is keep the first function as it is, differentiate second, plus keep the second function as it is into differentiate first. Very simple way. So, again be careful here, x e raised to x is algebra, e is exponential. We need to apply the product rule. So, x as it is, differentiation of e raised to x plus second function e raised to x as it is, differentiation x is 1 minus differentiation of log x is 1 by x. So, differentiation log of 1 plus x is 1 whole divided by 1 plus x. See, I am doing separately here, a whole divided by differentiation x square is what? 2x. Now, again you need to apply the limits. Okay. So, I am doing step each and every step here. So, again this will be, if you apply the limit, 0 into e raised to 0 plus e raised to 0 minus 1 upon 1 plus 0 whole divided by 2 into 0. So, this will be now again, see 0 0 1 minus 1 by 0, that will be again 0 by 0, indeterminate form. Again we need to again what? Apply the L'Hopital's rule. What does it say again? So, k is equal to limit as x tending to 0. Again differentiate this, x as it is, product rule here, differentiate e raised to x plus e raised to x as it is, differentiate x is 1 plus again there is one more term e raised to x, that will be e raised to x only. Now, differentiation of 1 by x is what? A very standard result we remember in engineering. Differentiation of 1 by x is, please keep in mind here, differentiation of 1 by x is minus 1 by x square. You need to remember this always. Differentiation of 1 by x is what? Minus 1 by x square. Pay attention to my words are designed to enter your brain and fit it there. So, differentiation of 1 by x is always minus 1 by x square. So, here minus 1 by 1 plus x is minus of minus 1 by 1 plus x the whole square. So, plus 1 by 1 plus x the whole square, whole divided by, now differentiation of 2x is 2. Done. Therefore, again apply the limit now. So, limit will be now, see 0 into e raised to 0 plus e raised to 0 plus e raised to 0 plus 1 upon 1 upon 2. So, e raised to, this is whole thing 0, e raised to 0 1. So, we have 1 plus 1 by 2. Therefore, the answer for this limit is k is equal to 3 by 2. That is all. So, what you get here was solving the limit, you get answer as k is equal to 3 by 2. That is it. Let us solve one more question here. It says evaluate limit x tends to pi by 2 log sin x by pi by 2 minus x the whole square. Again see fraction, numerator denominator. So, next condition is what? Assign k is equal to. So, k equals limit as x tending to pi by 2 log of sin x whole divided by pi by 2 minus x the whole square. After assigning k, you put the limits. What you get? This will be log of sine pi by 2 upon pi by 2 minus what is x? Limit pi by 2 the whole square. So, this will be now what is sine pi by 2? Sine 90 is 1 and what is log 1? I keep on repeating, log 1 is 0, log 1 is 0. So, 0 by pi is 0. So, we can apply the L'Hopital's rule. So, what does it say? K is equal to limit as x tending to pi by 2, differentiate the numerator upon differentiate denominator separately. So, differentiate log of x is 1 by x, chain rule. Log of sin x will be first log x is 1 by x. So, log of sin x will be 1 by sin x into again differentiation of sin x, chain rule will be into cos x whole divided by differentiation of pi by 2 minus x the whole square will be differential x is to n is n x to n minus 1. So, 2 into pi by 2 minus x is to 1, again differentiation of chain rule, pi by 2 minus x, pi by 2 0, it is a constant, differential minus x is minus 1. So, into minus 1, again this will be now k is equal to, I will simplify it, x tending to pi by 2 cos by sin is cot x whole divided by minus 2 into pi by 2 minus x. Again if we apply the limit here as pi by 2, see easily this will become cot of pi by 2 upon minus 2 into pi by 2 minus pi by 2. And what is cot pi by 2? 0. Tan 90 is infinity, tan pi by 2 is infinity, cot pi by 2 is opposite of it, it is 0. So, it is 0 by 0. So, again we can happily apply the L'Hopital's rule. So, again k is equal to nothing but limit as x tends to pi by 2. Now, differentiate the numerator. Differentiation of cot x is what? Minus cosecant square x. Differentiation of tan x is secant square x, cot x is minus cosecant square x. So, we have minus cosecant square x whole divided by minus 2 into again differentiation of pi by 2 minus x, pi by 2 0, differentiation minus x is minus 1. So, into minus 1. Therefore, k will be now minus minus cancel. See cosecant pi by 2, sin pi by 2 is 1, sin 90 is 1, cosecant is opposite of sin, 1 by sin is cosecant. So, obviously cosecant pi by 2 is also 1, sin pi by 2 is 1, also cosecant pi by 2 is also 1. So, this will be now minus 1 divided by this minus 2 into minus 1 is plus 2, that is it. Therefore, k is equal to minus 1 by 2 is the answer. So, the answer for this limit is k is equal to minus 1 by 2, that is it, as simple as that. Let us solve couple more questions here. Evaluate limit as x tends to 1, x by x minus 1 minus 1 by log x. See what is the problem with this question. First condition is what? The question should be fraction. This is not a fraction. So, let us make it a fraction here. So, let us take LCM. So, we have first we assign k is equal to limit as x tends to 1, x by x minus 1 minus 1 by log x, and the problem is it is not a fraction. So, take the LCM. So, we get k is equal to limit as x tending to 1, x minus 1 into log x and x into log x minus bracket x minus 1. Okay. Now, we can apply the limit here. See, after it is a fraction now. So, apply the limit and check whether we can apply the L'Hopital's rule or not. Okay. So, we have 1 into log of 1 minus 1 minus 1 whole divided by 1 minus 1 into log of 1. So, log 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0, log 1 is 0. So, we get 0 by 0. So, we can apply the L'Hopital's rule now, and what does the L'Hopital's rule says? Differentiate numerator upon differentiate denominator separately. So, let us do it here. So, we have k is equal to limit as x tends to 1, and let us differentiate it. There is a product rule here, x into log x is first function, log is second function. Differentiation of first into second function is keep first function as it is, differentiate second, plus keep the second function as it is into differentiate first function. Okay, so x as it is, log x is 1 by x plus log x as it x is 1 minus x minus 1. So differential x is 1 whole divided by, again x minus 1 as it is, differentiation of log x is 1 by x plus log x as it is, differential x is 1. That's it. So again if you simplify this, we get k is equal to limit as x tends to 1. See here x cancel, 1 minus 1 is 0. So what we get? We get log of x whole divided by, again this will be x into see x into open bracket 1 by x is 1 minus 1 by x plus log x. Fine. Now let's apply the limit again. So we get log of 1 whole divided by 1 minus 1 plus log of 1, that will be again 0 by 0, right? Log 1 is 0, 1 minus 1 is 0, and then log 1 is 0. So again apply the L'Hopital's rule here. So limit as x tending to 1. Okay, so simple differentiation, numerator separate, denominator separate. Differential log x is what? 1 by x. Okay, whole divided by, again this will be differentiation of 1 is 0. Then differentiation 1 by x is minus 1 by x square. So minus plus 1 by x square plus 1 by x. Now again apply the limit to it. So we get 1 upon 1 upon 0 plus 1 plus 1. So that is 1 by 2. Therefore the solution for this limit is k is equal to 1 by 2. That's all. So we have the solution here as k is equal to 1 by 2. That's it. How simple was it? Correct? So follow the basics for the procedure correctly, you will get a right answer. The last one here is evaluate limit as x tends to 0 tan x into log x. So again it's not a fraction. So first let's assign k is equal to limit as x tends to 0 tan x into log x. I cannot solve it because it's not a fraction form. So let's make it a fraction. Use the basics. So how can you make this fraction? We can rewrite this as k is equal to limit as x tending to 0 log x. We cannot do anything as it is, but tan x can be written as 1 by cot x. 1 by cot x is tan x opposite. So we can write tan x as 1 by cot x. Now this is fraction. Again apply and see what happens. Log 0 is what? Infinity. Cot 0 is again infinity. Remember these two things. Log 0 is always, log 1 is 0. But log 0 is infinity. Tan 0 is 0. So cot 0 is again infinity. 1 by 0. Okay. So we can apply L'Hopital's rule here. So k is equal to limit as x tends to 0, differential log x is 1 by x, and differential cot x is minus cosecant square x. So this we can rewrite it as is equal to limit as x tends to 0. See, the reciprocal of sine is cosecant. Okay, 1 by sine is cosecant. So 1 by cosecant is sine. Great. 1 by cosecant is sine. So we can rewrite this as minus sine square x divided by x. Right? Minus sine square x divided by x as x tends to 0. Now we can again rewrite this as k is equal to limit as x tends to 0 into sin x by x into sin x minus sin x. Right? Why I am writing is because there is a very standard limit. These limits will be used to make the problems easier here. I hope you are aware of this limit. The very standard limits, those are, one is limit of sin x by x as x tends to 0 is equal to 1. Also limit of x by sin x as x to 0 is 1. Also tan x by x as x tends to 0 is equal to 1. And also limit of x by tan x as x tends to 0 is equal to 1. So here it is, see here, it is sin x by x as x tends to 0, and that is equal to what? 1. Why? Because we have limit as sin x by x as f tends to 0 equals to what? 1. This is a standard result. So, the result limit as x tends to 0 or limit sin x by x as x tends to 0 is always equal to 1. So, here both are satisfied, Cx is tending to 0 and sin x by x 1. So, put the value here. So, sin 0 is 0, therefore, k is equal to what? 0. So, k is equal to 0 is the answer here. That is it. Okay. So, we need to remember these limits. Again I repeat, the limits are limit of sin x by x as x to 0 is 1, also limit of x by sin x as x tends to 0 also equal to 1. There is one more, limit of tan x by x as x tends to 0 is 1, and also limit of x by tan x as x to 0 also equal to 1. That is it. Those will make, you can obviously differentiate it, but these things will make the problem shorter and easier and the accurate answers. That is it. So, that is all for today's video. We have solved today some basic problems relating to L'Hopital's rule. The next video I will be solving problems on L'Hopital's rule involving trigonometric functions like sin and tan, which are very important for with respect to examination point of view. So, do not miss the video, and if you haven't subscribed, please hit the subscribe button right now, like it, share it with your friends as much as possible. So, always remember, keep practicing. The more you practice, the more confident you become. Till then, happy engineering, best of luck for your exam. See you in the next video. Bye.